Well, shall we get on?
I'm just preparing my mind. Hello, my aviation chums. Welcome to A Chopper is Born. Today, we're going to be putting on the rest of the pulleys and belts to run the tail rotor and putting the clutch in, and also the chain oil bath. You can't wait, can you? When it gets hot, it actually tightens rather than slackens. So your life is in the hands of this belt. If it had hands, of course, which it hasn't, because it's a belt. People have hands, belts don't. First job is to put on a test marker for heat, which has got to stick onto this pulley. And basically you can see here, there are 170 here, 180, then 190 and 200F. And it's a heat detector. Now if the pulley itself reaches 170 degrees, that little silver dot next to the 170 will turn black. That's a warning sign when you're doing maintenance. Maybe you've got a loose belt. Now that's got to be stuck on there. First job is to just clean up with acetone, just to get rid of all the rubbish. And then you borrow Pete's nail varnish.
It's not mine.
It is yours. Look, don't fight it, Pete. And then it needs to just go off until it's tacky. How long does it normally take yours to go off, mate?
About a minute.
About a minute, okay, cool. But it's a bit cold today, so it might take a little bit longer. Okay, leave that for now, just to go off a little bit. The attachment of the pulley to the bulkhead is very straightforward. It's a couple of scissors. We need to put on this bit, which is the spindle, and then it'll attach the pulley with these two little hubs either side, but I'll put those on once I've stuck the sticker on. Right, now, that looks tacky. When you going to start using colour, mate, rather than just clear? No? There we go. No problem at all. Put these two hubs in and fit the scissors. And then a bolt goes through the two. Right through. There we go. And there you have it. One assembled pulley, all needs tightening up, and then I can put it in the aircraft. The pulley fixes onto the bulkhead in here, and fortunately in the tail boom there is an access panel which allows you to fit the pulley, and also obviously to check that heat strip when it's all built and running. The scissors just slip into a bracket with a couple of holes in that's already fixed to the bulkhead, and then there are just a couple of bolts. One there. First one went in beautifully. Now this one. Come on! Have you just got a pin I can put through here to just check this is in line? Oh, there we go. And then it's a case of popping in the bolts. Oh, where's that gone? Oh, there it is. Yeah. And this will not go in. Oh, come on. The simplest job is always the most difficult. Right, just tighten those up and then I can take the pulley out. That is the end of that sequence. The pulley's out, here's the belt. It goes onto the bottom of the two slots in the pulley, like so, but I need to feed up first the belt down to the end. The belt coming from the tail rotor end needs to be in the top groove of this pulley, like so, and then the whole lot needs to slide into the scissors, and then one big bolt through the whole lot, like that. Right, well this axle bolt for the pulley needs to be done up completely tight, and then I can attach the belt to the secondary drive. So, the belt should, just pull it taut, should just slip on to there without having to stretch it or anything. Now, does that move the tail rotor? Yes, indeed! The magic of science!
CNC is computer numerical controls. It's a 4-axis, 5-pallet, horizontal milling machine. This machine can face off parts X and Y axis and Z axis, so you have three-dimensional milling, and the pallet will also rotate, which gives it the fourth axis. This machine new is, with its tooling, is about $1.5 million. Tombstone is the big square block that we're going to mount the parts to. The operator initially is going to bring the tombstone over into the loading station, the loading dock. He will physically load the part onto the pallet. The operator will then activate the program that's going to machine that part. And here we have a panel that we use to activate the different programs for the different parts that we have loaded in the machine. This machine has 96 tools that are ready for whatever operations that we're going to do. The machine will automatically rotate those chains around, bring up the appropriate tool, and load it into the machine. This is the inside of the case. So these are the two mating surfaces that are completely flat now. On the back side of this tombstone, we have cases that had already been machined, and the opposite face was cut perfectly flat and parallel to this interface. Here we have the cases which have just been fly cut. We can see the pallet coming out. The point of having this machine in the factory is so that we can get very accurate to within a half thousandth of the tolerances, and we can have this repeated time and time again and get consistent parts.
Next job, the clutch. Pete, mate?
Yeah.
Have you got the basic assembly for me?
Is that it? I mean, it doesn't look a lot.
It doesn't look a lot, does it really?
No.
But this is the main workings of the clutch, which there's quite a lot of assembly work to do on its bracketry, but it will fit in here, something like that, which means when the clutch is engaged, this arm will move this big pulley here out sideways, like so, which will tension the belts, and that's controlled with a rod lever that goes through into the cockpit. So it's a bit of a bench job. Okay, please take a long, hard look at this plan, and when you've worked out what it's all about, could you let me know? This is a very complex looking drawing, but if you get rid of all the kind of superficial stuff you don't need to know about and concentrate on the middle, you can see there's the top of the pulley looking down on it. And this is the main frame it sits in. That's the arm that goes to its hinge point there. And then we've then got this connector here, a bracket there, and then this that continues here is actually the lever that goes into the cockpit, which is there. So you can kind of ignore everything else on there for the moment. And the first job is to properly attach the pulley to this arm here, which is number 21, which is the pulley arm weldment, E279010. Next up is preparing the clutch tube weldment, which is this bit. We've got some springs to go in there. This will slide in there like that. Well, Pete, mate,
Yep.
can you just drop that rivet in? All right, mind your nails.
Yeah.
Mind, just use the base of your thumb. Okay. Sorted, and there you can see it just acts as a stop, a backstop for the piston. But the piston is free to move up and down like that. Right, that's the pulley and its arm attached, so it can swing there and engage the pulley onto the belt. Next, the other clutch arm, which has one bolt underneath and then another bolt in the top, like so. And you're beginning to get the idea. So that's it for now. Don't go away though, join me after the break when I'll be putting in, now which way around was it, Pete, mate? It's the chain oil bath. Not the oil chain bath, isn't it? That's the one, in a couple of minutes. Welcome back to A Chopper is Born. My two-seater executive helicopter is evolving very nicely. Now you can tell that firstly by looking at the helicopter, and of course we've got more bits on it than before, but more satisfying is the fact that my empty tray is filling up very nicely. We're just finishing off the drivetrain for the helicopter, which basically takes the turning of the crankshaft of the engine down here through a system of pulleys and cogs to be able to drive the tail rate at that end, a few other bits and pieces that are to do with the engine, but also the big wheel up here that turns our main rotors. Last job before the break was just fitting the clutch here, and you can see now that that works very nicely. When it's engaged, this over-center arm here locks into place and pushes this pulley right out to tension the main belts. But when you take it off, what is very obvious is the main belts are far too slack. So I've already tensioned up the drive belts that go to the tail rotor, and the same principle is used to tension these main belts. You need a gauge, a bit of wire, and a little piece of aluminium cut to 1/2 inch on the end of a piece of string. All will become very clear in 2 seconds. The adjustment for the belts is done down here on this bolt. As you screw this in, it pushes the top of the engine towards the front of the aircraft, which tensions the belts. Okay, that's tightening up a bit, so let's see whether we're anywhere near the tension we need. So what we do is get your bit of wire, hook that underneath the bottom belt, attach the gauge to the other end of the wire, and then this is effectively your depth gauge or marker gauge, because the belts are at the right tension. When you're pulling 7 pounds on here, the belt should move out of position the 1/2 inch width of this little piece of aluminium. So we've got 7 on there, and you keep fiddling about until you get it right.
Welcome to Oshkosh. My name's Craig Hook. I've built a Rotorway Exec 90, manufactured in 1991, got it together in 93, and been prettying it up ever since. It took 575 hours to get the machine together and flying, probably 1,000 hours more for the paint and the interior, the other fancy things that we put on it. They make their own engine. It's a 162-inch displacement, water-cooled 4-cylinder. They call it a Rotorway 162F. The F stands for FADEC, or fuel injected. 150 horsepower. Turns the blade 520 RPMs. Tail rotor's about 2,600 RPM. We didn't have any main problems at all. The manuals were very explicit with their detailed drawings. Very straightforward. You need to be able to turn a screwdriver. You need to be able to fabricate some parts, but nothing that the average person, I don't think, is going to have a stumbling block.
This is the chain oil bath, although it needs a bit of fabrication. It comes in 3 bits. 2 bits make the lid, but we're not working on that at the moment. Ah, just looking for that. Pete, mate?
Yeah.
Found it.
No, thanks a lot.
It's yours, all right. Over here is where the oil bath will go. And this main tooth cog will sit in there. And the other one that sits on top of there for the other end of the chain will be inside here. And it is to bathe and lubricate the chain. It's got to contain oil. But no ordinary oil, because it's a mixture of good high quality engine oil mixed with this very gloopy stuff that is very like treacle, almost good enough to have on your porridge in the morning. And that thickens it up nicely. So it's not a huge amount of oil goes in this bath. And actually one of the jobs first thing in the morning when you've got the helicopter complete is you tip the helicopter back a little bit so all the oil in the bath runs back down to coat the small cog, and that then will get all the oil on the chain, so when you start running up you've got the whole thing lubricated. First job on the bath itself is to cut 2 holes, one for the primary shaft, one for the secondary shaft. what I'm doing here is creating a little access hole where we'll end up putting in this link pin here for the chain. That'll go up through that hole. So it's only a little hole, but the next bit of kit to open up the slot is this thing, which is a step drill. It means you can start with a pilot hole and then just open it up to whatever size you want in one go. So. Oh, yes! There you go, that looks good, excellent. This will then sit over secondary shaft, like so. And I've got an oil seal here. This will glue in place finally, but be left dry for now, but that'll help centre that end. So that's fine. Now, the idea is I've got a mark from underneath where this square section tube on the airframe is, because I'm going to need to drill 2 holes down here to fix this to the airframe. Pete, mate, can you just keep this end centred while I try and mark it underneath? There and there. And then we can drill it. I've drilled the 2 holes in the square section tube there, and I'm just putting on some non-corrosive silicone. Right, I think I'm ready for chain bar. Wait, look. If you can take that off, clamp off, and then take the 2 sleeves. Got them?
Look at that.
Coming down. Give it a tap. It's not Morse code, it's trying to get the thing in the bearing. That's it, it's slotting in, it's going, it's going, it's going. Lovely jubbly. Now we need a little cog, the other end. I need to clamp on this cog onto the secondary shaft, so it's just a process of sequentially tightening up these Allen key bolts to effectively squeeze the cog onto the shaft. Okay, sorted. Next, the chain back on.
Taking off from the ground. I'm going to bring up my RPM. As soon as I get RPM, I'm immediately going to pull pitch. I'm not going to come to a hover. As I leave the ground, I'm going to immediately start forward into forward flight. There we just entered translational lift, which is basically increased performance due to more airflow through the rotor disc as you gain airspeed. Execute a normal takeoff from the hover, we begin taxiing forward, continuously increasing our airspeed. At 15 miles an hour, we enter translational lift. I'll maintain 65 miles an hour on my climb. That's going to give me my best rate of climb. Okay, to execute a max performance takeoff, as I begin my forward takeoff movement, I increase collective pitch and throttle to maintain rotor RPM, and that establishes a more vertical climb to climb out over a confined area to clear an obstacle. Once we're clear of that obstacle, I reduce the power back to the hover power setting and resume a normal climb out profile.
I've linked the chain together from the top with an old connector link, but you can now see why this little access hatch is in the bottom here, because the actual pin it's got to come up from the bottom, and then as it comes out, to put in some little spacers in the chain. Last little link over the top, and then this clip, which will be eventually painted white so you can see it more easily. There we go, one chain sorted. Now there's quite a lot more work to do to this in fabricating the lid, also putting a safety spacer on the main shaft here. But once all that's done, we can put the oil mixture in and seal all that lot up. But first let me show you how this will all work in normal operations. The engine here will drive the primary shaft here with the belts on. These will take the rotation back to the secondary shaft here with the big pulley on, which connects with the tail rotor, but through that secondary shaft, and then the little cog on the top and the chain drives the big cog here, which drives the main shaft and the rotors. That's all good and well, but what if the engine fails? Well, thanks to the freewheeling sprag clutch in the secondary, as the blades continue to rotate, with the engine stopped, you can keep your tail rotor turning, which means you have complete control over the helicopter to get back down to earth safely. Now that is a very cunning, life-saving bit of engineering. That's it for now. We'll see you next time. Pete, mate.
Yeah.
Park it in its normal place.
Okay, right.
Welcome to A Chopper Is Born. I'm about halfway through building this two-seater executive helicopter. Now, things have moved on a little bit since last time. Finished the chain oil bath here, got the lid on and everything. Also put on here the safety spacers that go around the main shaft. They're just clipped on here, but all the bearings up here have all been Loctited. Down below, the counter shaft is now on. This is driven by a belt from the secondary shaft in here, and all that does is drive the very expensive fan blade that's now fully fitted and bonded in place there. So that's sorted. Round to the side. The alternator is in place, and down here, the oil filter. Next job, exhaust. Just a little job that I have to do is to put on heat wrap, which is this stuff, onto the exhaust, which is this bit. The point of doing this is obviously a lot of heat is going to get generated by this exhaust, and covering it in heat wrap just protects those more delicate parts of the engine compartment. At times like this, that years of plaster casting animals with broken legs comes in very handy. It's best to take your time with this to get it right, but it's actually a very satisfying job, and we're nearly at the point where this is finished. It will take 3 or 4 days to dry out. If you want it to take a little less time, the thing to do is take it into the warm, shift grandma out from in front of the fire and put it in her place. When it's dry, it gets painted up with fireproof paint to stop any oil or anything getting stuck in it which could be a fire hazard, and then it can get fitted. Lovely, jubbly. There you go, all wrapped, all painted with heat-resistant paint. Doesn't it look gorgeous? All I've got to do now is fit it. I put some tape over the exhaust ports to stop any debris dropping in them, but obviously take that out before I actually fit it. Now, this is a bit of a tight squeeze to get up here because the airframe tapers back where it's got the tail boom supports. That goes up there, like so, and then should be good. Drop onto there like that. Now, with that roughly in the right place, I can then think about gaskets, just 3-cornered and quite cleverly got a little handle on this side so that you can just joggle it about a bit when you need to. First off, I just need to remove this tape. Make sure there's no debris. And I can drop this on. It's very important to put this back bolt in first because it needs to be threaded in a little way so that you can actually get a spanner on it when the rest of them are in because of the curve of the exhaust. So I need to just rock it slightly to give myself some clearance. So that's it. These are little 12-point bolts here, which is quite convenient because it means you can actually latch the spanner on at many more angles than a conventional bolt, and there's not much room here, so right, that one's gone down enough, so that's 1 down, 11 to go.
This is your engine for your helicopter. It's 162 cubic inch, 150 horsepower, 4-cylinder, horizontally opposed, liquid cooled. Basically made up of the engine case, jackets, heads, and coming around we have our intake system, the air and fuel. We have the starter and the pulley that drives the system. We start out with the raw castings of the jackets, the heads, the case. We will do all of the machining of that casting here. Here we have the jackets that have coolant flow through them. They come to us in a raw casting state, and the inside is machined to accept the cylinder sleeves. The cast iron cylinder sleeves are pressed into place to accept the seal. We then are going to hone them, and they're ready to load with the pistons. The heart of the engine is the crankshaft. We get it as a raw forging, and it takes a lot of work to get this ready for your engine. Seats and guides get pressed into the depressions that are made for them in the head. The valve guides, we do some work on them here and then press them into the appropriate bore for the intake and exhaust valves. And now they're ready to insert the valves. Here's a head that has the valves installed, and from the bottom here we can see the intake and exhaust valves have been inserted in the guides. On the top we have the valve springs and spring keepers. Here we have your engine going together. We've added the connecting rods that are going to connect the crankshaft to your pistons. We've inserted the cam and timing gears. The other case half will be assembled to this, and we're going to end up with the short block. Later on in the series, we will turn this short block into your completed engine.
You haven't seen a radiator anywhere, have you? There it is, lurking underneath the cardboard. This job is to attach a fan shroud to the radiator and to put on this fan ring. 3 bits. First job, though, is to put on a foam sealing strip all the way around the edge of the radiator. Where's the end from? Next, I can fit the shroud. Now, the radiator itself, you're probably thinking, that is a big radiator for not a very big engine. But the way helicopters work is that that engine will be going at over 4,000 revs permanently when you're actually using the helicopter. So it does run very hot, so it needs a serious amount of cooling, hence a big radiator. That drops over like so. And then when I do this do the bolts up on this, it will sit, just cover that hole up, don't want any rubbish going in. It will squash down that seal. There we go, it's just 4 bolts with big washers. Last bit on is the fan ring itself. I've put a bead of silicone around there as a sealer. Now this needs to drop on. I've marked on it that that's front there, so that's going to be that side. Now to line it up so we don't smear the silicone everywhere, I can drop this down here, and there's a hole at the top here. And this just drops it down without smearing it too much. Holds it in the right kind of place. And then it's all pop riveted. Now Pete, just drop this in very carefully. Yep. The fan is expensive.
I come down on my knees, you think?
Yeah, pray you don't break it. So it slots up into the ring, okay?
Yeah.
And then have you got it near that bracket on the tail boom support brace?
There.
Yeah.
Got it.
And got the back as well. You got the weight?
Yeah, got it.
Okay, right. I'll put the bolt in this side. Let's fit this spacer on the far side of this bracket. This bolt will be wired on to the hole in the frame here eventually. 2 seconds, Pete. Okay. You all right, Pete?
Yep. Knees are going a bit, but...
They were going before you started.
That's true.
But no, that's not the way to do it. It was nearly in there, Pete. Little washer, big washer. It's looking a treat. Lovely jubbly. A couple of brackets at the back to sort out. But that's it for part 1. Join us after the break when what will we be doing, Pete?
Ooh, something or other.
Thermostat housing.
That's right.
You tired?
Oh, my knees.
Cut! Oh, my knees. Next is the thermostat housing. Calling all viewers of A Chopper is Born, we're building a thermostat housing. This is it. And this is the other bit. It's a lid and a base, and the thermostat drops in like so. And this thermostat is very like the one that you will have in your car. But I bet you've never, ever, 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 ever seen one working. Until now, that is. And then the water can go through. Yeah, that's hot! So, putting it, you liked that, didn't you, by the way? That was a nice little bit of science. Bit of workshop science for you. Now, first job to put it all together is putting a little bit of silicone around the base, just as a sealant. Just squidge this round. There we go. And that drops in like that. Then the thermostat just sits in its little rebated seat. And then the top just squeezes on like so. And then it's just 4 nuts and bolts. Connected some of the hoses to the thermostat housing. There's the 2 main ones, top and bottom, and then 2 other pipes come off it. This one is a bypass pipe for when the thermostat's closed, and this one will go to the oil heat exchanger. The whole unit nestles between the exhaust pipe here on this side, the back of the engine, and in front of the radiator and the fan shroud. And the bottom hose off the thermostat housing goes straight into the radiator, which drops on a tree, like so, and then up above goes onto this pipe rail, which I just need to bring back, yes, and in she pops like that. And then we can move on to the oil heat exchanger, in fact fabricating a strap to attach it to the aircraft.
Welcome to Oshkosh. My name is Michael Solano. I'm the factory test pilot for Air Command International and was the first one to fly the centerline thrust Air Command. The aircraft like this one here can be assembled by a novice in 150 to 200 hours. You don't have to do any welding except for welding the muffler up to fit the aircraft. All of the holes are already pre-drilled. Some of them may be pre-drilled smaller and you have to enlarge them to make the assembly. Starting price on the 2-place trainer like this is $19,000, and then you can start adding options on. Wheel pants, enclosure, pre-rotator. Gyrocopters have only one bad tendency, and that's the pilot. If he pushes the stick forward too fast, the rotor blades will stop on these aircraft. Just in case that happens, as we have the ballistic recovery system mounted underneath of ours. It's a parachute. It shoots out the bottom of this machine, and it comes down and it lands on its wheels.
Can you guess what this is?
I don't know.
He doesn't know, but you should. It is an oil heat exchanger. It's a sump because it's the reservoir to hold the oil in. In the top here's your filler cap attached to a dipstick, and you actually have to put the mark on the dipstick because it's a kit helicopter, so you have to do all these little things yourself. And if you have a look inside, you'll see that this helicopter actually has two radiators, the big one, and then another little radiator that's inside this oil sump. And the idea of that is that the water from the engine, from the cooling system, flows through that little radiator in here. The oil from the engine, which sits and flows through this sump, surrounds that radiator, so it means that both the oil and the water from the engine are kept at the same temperature, which is good news for the engine. What you have to do, though, is fabricate a strap to attach this to the aircraft. All the instructions are in the manual. It's made out of a piece of steel, and you've just got to bend it to the right length, drill a couple of holes in it, and you're sorted. So, first job, bender, this way. Sorry, this way. This is a bender, and it's a serious piece of kit. It is not essential to wear goggles using this machine, but it is essential to have reinforced underwear, because if you stand anywhere near this handle, you will get a serious whomping. All you do is you open up the jaws like that, you pass in metal, like so, then clamp it with this lever, then pull on the whomping handle, and then gradually bend this up. It needs to go a little bit past 90 degrees because it will spring back, but not too much past, otherwise it will be difficult to rectify. Looks good enough to me. Glad to say nobody got whomped. There you have it, look, a right angle bend. Lovely. To mark up where the next bend is going to be, you need to get some of the rubber strip that's going to run on the inside of this bracket. Get two thicknesses of it and put that just against the edge of my first bend, like so. Slot in the heat exchanger, and then I'll know exactly where to bend the other end just by simply marking along the edge of the sump. There we go. I'll square that off with the square. A couple more bends, then I can spray it all up, stick on the rubber, and then I can put the whole lot into the aircraft. Here it is, all sorted. There's the bracket along the bottom. You can see the rubber in there like that. Now it fits in here, behind the pilot.
Straight and level flight. Again, for the beginner, he can reference the compass to the horizon to notice the pitch attitude of the helicopter, and he can control that with the cyclic. For instance, if the nose of the helicopter is dipping down, so applying aft cyclic would pull the nose of the helicopter back up. Collective control of straight and level flight is used primarily to maintain your altitude, which you can reference either off the vertical speed or the altimeter. You see that you're climbing or descending, you can adjust the collective the opposite direction to compensate for that. Turns in forward flight are initiated with the cyclic pitch by applying pressure in the direction you want to rotate the aircraft. In a steep bank turn, you would also increase collective pressure to maintain altitude, and you therefore need to coordinate pedals. This is where you can get yourself into improper pedal control during a turn and put yourself into either a skid or a slip. A skid would be when you have too much pedal in the direction of the turn, and a slip is when you have insufficient pedal in the direction of the turn. Small, shallow turns in the helicopter are done primarily with the cyclic. There's no pedal input because you're not making a power change at all.
Next job is to put on all the oil system and cooling system hoses, and you do get a couple of plans here. This is a kind of topographical plan that shows you what connects to what, and then there's another one underneath which gives you more detail about what it should actually look like when you look at the side of the aircraft. And I've got all the pipes No, I haven't. There's another one. So that's another pipe. I have no idea where that goes. Now, what I do know is that these are oil pipes. They're very special. They are Teflon pipes underneath this stainless steel coating. And where these come close to anything else, they have to actually be a protective covering, because it acts like a bit of a file, this stuff. But they last forever. So, start with something you know, that's the thing. And I know where the thermostat is, and that's there. So I want a pipe that connects the thermostat and the oil sump heat exchanger. So that should go from there to there. That fits a treat. The expansion tank goes up here, I know that much. This is the inlet side of the water pump. Next is the bypass pipe from the thermostat housing. We'll do that up later. Then this side of the inlet manifold goes up to the expansion tank. Like so. That looks nice. Now, what about some oil pipes? I'm going to connect up the oil filter here, which is a disposable cartridge filter, to the bottom of the engine. 2 pipes, there's an in and an out on the oil filter. Now these oil pipes, when you connect them, you take out these protective end caps, and then they need a little bit of oil smeared on the threads inside here, and also the threads where they connect to stop the aluminium galling, which is when you get a little burr on it that might form. And because it's quite soft aluminium, when you then grind the two together, it'll create a groove in the aluminium. Just a little bit. So this one is the out one. Send on. Well, that's nearly it. Only a couple more pipes and hoses to go. My chopper is about halfway through its gestation. I'll see you next time when I'll be sorting out the fuel system. Pete, mate.
Yeah.
Park it in its usual place.
Okay, mate.
Welcome to A Chopper is Born and my workshop. One of these days, when I pick up a piece of kit that I put on one of the things I build and blow into its orifice, I'm going to get a beautiful sound out of it. Unfortunately, this isn't going to be the piece, because this is the exhaust pipe from the helicopter. It's just one of a whole lot of bits that I'm going to be putting on today. Feast your eyes on this lot. Basically, all this here is the fuel system, and probably the only bit you'll recognise as being possibly something that you might have one of in your car, but not this shape, because it's got a hole in here. This is one of 2 fuel tanks. Shall we get to work? The muffler or exhaust itself is stainless steel. It's held on by a couple of straps at the back that attach to the radiator, and then 3 bolts that clamp it onto the end of the exhaust that's already fixed on the engine. So we'll just whip these nuts off, plonk that through there, like that, and then I can start attaching it. This is effectively like a bit of a ball joint, which means that there is the ability for this to move slightly in relation to the engine and still keep it sealed. There we go, that's one. Hey, there's a runaway. That's a Pete. The helicopter is now more than halfway complete. It's getting very exciting because it really is starting to look like a helicopter now. Even Pete's excited, aren't you, Pete?
Not a lot, no.
Right, that's it. The muffler sorted. Next up, the fuel system. A very quick explanation of how this fuel system is piped. You've got a fuel tank either side. The fuel comes down here through this isolator, down here, around these pipes, through these. Those are those fuel pumps, 2 fuel pumps, round here, through this, through the filter, into the injectors. Have you got that? Good. Right, let's get on with it.
Right, I've got card E253F. It's got 2 fuel pumps and a fuel filter. I don't know what to do with any of this, Mark.
Cut the rubber to fit on the filter mount bracket.
Sorry, I can't hear you. I'm going a bit deaf. Can you say that
Cut
again?
the rubber to
Yes.
fit on the filter mount bracket and glue
I
it in
haven't got
place
the
with
rubber
weather
here.
strip adhesive. Make it sound as though you know what you're talking about.
Fuel filler cap.
Pete,
What?
how's it going for you?
Not very well. Sorry.
It's presenting
Yes,
presenting
very-
not your forte.
It's really difficult.
It is. It's harder than most people think, isn't it?
Yes. When you're working with professionals like you, it really is difficult.
Isn't he nice? Now get out of my shop.
Okay.
Go now. What we're going to do is we're going to put all this lot on the helicopter, and the first job is to cut one of these, and it's cut. How easy was that? Just put a bit of glue on this plate on the airframe, and also glued up the rubber, having rubbed it down with a bit of sandpaper first. That just needs to go tacky. And then on top of it will sit this, which is the fuel filter. It's got arrows on it which tell you which way the fuel goes, and it will sit with the big end out here. So I'll be able to pop that on in a second. We'll let that go off a bit, and then come round your side, because I've got 2 fuel pumps to put on, which are on my card, E25, card 3F, and they go that way up. They go with their negative terminal, so you avoid any chance of sparking. And they're held on by big clips down here. Pumps are held on by 2 clips on each pump, and it's a little bit of a fiddle trying to get them through this plate. The difficulty is not just getting them through the plate though, it's getting them so that the screw on the end of the clip is actually accessible afterwards to do it up. So you need to get it roughly in the right position, and then I'm just going to mark it where the holes are, so once I poke it through, it should do up fine. It's there, like that, and then feed it through. This is very fiddly because the 2 slots in the plate are so close together that you can't follow the natural curve of the clip.
In a previous session, we ended up with a short block, which includes the crankcase, the crank, and connecting rods as a subassembly. We now add the jackets. And the jackets already have the pistons in them as we attach to this short block. The next step is to attach the head. From that point, we're ready for the intake system. And the intake system consists of the plenum and intake runners. The plenum starts out as a raw casting, which we machine. We then press in some bearings, and we add the fuel rail and fuel injectors, the throttle shaft, the throttle plate, the sensors, and fittings. And here we have the completed plenum assembly, and you can see that we have the throttle plate installed and operational. Now that we have a completed plenum assembly, we are going to take the output from that with a flexible coupling to the intake runners. The intake runner assembly is a casting which we machine, and to that we're going to attach the fuel rail and fuel injectors. And here we have the completed intake assembly. As we follow back, we can see the fuel injectors, 1 per cylinder, the fuel rail to which we will have the fuel lines connected, feeding your engine. As we come back to the plenum, we do have the throttle position sensors that are going to feed information to the FADEC system, an air temp sensor, 2 secondary fuel injectors, and our manifold pressure sensors. This whole assembly can now be attached to the heads on your engine.
2 pumps are sorted. I'm now putting in the fuel shut-off valve into another clip here. There we go, in like that. It's got this lever on the top here, which controls the shut-off valve, and that's wire controlled through into the cockpit. The 2 connectors here come from the tanks either side, and then its output comes round and into the fuel pumps. There's also a little filter in this cut-off valve as well, which is a kind of pre-filter before the pumps. So that goes in there like that, and then it's a matter of just bolting through with a couple of spacers. Next piece is the fuel pressure regulator, which is this bit of kit here. The fuel will come in from this end. In the top of here will be a sensor, and it means that once the pressure's built up to 60 psi, any excess fuel can come out through the back here and bypass, so it goes back into the tank, so it's permanently circulating, and it just drops very conveniently into this bracket here. Once I've got this on, next job is just whack the main filter in, and then we can do some pipe work. This is the smallest little ratchet I've ever seen. Rather than twiddling a knob to change the direction, all you do is just push the end through like that. Great Christmas present for the wife. If you think it looks complicated, it is, and I will try and take you through it. You start over here, with this pipe brings in the fuel from the tank on that side, and this pipe over here, which runs underneath, brings the fuel into this T-piece. It then goes through the shut-off valve here and the first primary filter in there, through the fuel pumps, back out here and here, through to another T-piece that's on the input side of the fuel filter, goes out of the fuel filter, up this pipe, into the fuel rail, down this side into the pressure regulator, which is down that pipe and into the bottom of here. In the top of there will be the sensor, and then if there's any overload to get rid of any fuel, it goes up this pipe and is circulated back into the tanks. Have you got that? I thank you.
Well, thanks very much, Mark, for all your help and advice and putting that lot together. Shall we get on?
Do you want to do the link, Pete?
Yeah, go on then. Time for a break. Join us in a couple of minutes when Mark will be putting...
My pen ran out. It's the fuel tanks. Welcome back to A Chopper is Born. We're doing the fuel system, and it's time to put in the tanks, of which this is one of them. They're made of polyethylene, which is about 10% heavier than aluminium, but much, much stronger. They've already got on their heat protection stuck on here. There are 2 holes in each tank, one at the bottom there, which is where the fuel will come out to go towards the pumps, and we'll be putting a fitting in there in a second. And the other is this end, because obviously you need to get your fuel in. And there's a pretty standard cap that goes in there, which can let air in and out. It's a pretty standard, much like a car. Now, the fitting needs to go in this end, is this little doobry here, which is quite a clever fitting, because obviously it's got the holes in here that the fuel goes through. They join up with the centre of the bit there, so that's fine, the fuel can get through it, but sealing it into the tank is a bit of a problem, because you obviously can't get inside to be able to put a nut on the inside of the tank. So it's got this sealer washer here, a rubber. Now we pass the whole lot of this into the inside of the tank, put the rubber so it lines up and it's lying right in the hole there. As you do up the rubber, it expands to a bigger diameter and then seals the rubber into the cutout in the tank. So this will slot in here. Fitting these tanks, because you have to make the straps to attach them to the airframe yourself, is an interesting exercise and involves this cargo strap. So, Pete,
Yep.
what I want you to do now is drop that tank, heat shield towards the engine.
Yep.
So that drops in there. Just support the bottom of it again.
Yep.
Got it?
Got it.
You got it?
Yeah.
Right, hold on to it. Hold on. Move your other hand. And
That looks good. Yeah, done.
I mean, it does beg the question, why bother with metal straps when you could just lash it on with this? A bit of baler twine. Going really well. Good. Okay. Run.
Welcome to Oshkosh.
My name is Don Terry, and this is a Safari helicopter kit. It's a straightforward kit and relatively easy to do. It's got an 0320 Lycoming engine, 160 horsepower. The transmission and drive gear is all part of the kit, and it's a vertical mounted engine, standard aircraft engine. The kit manufacturer does a real nice job of producing the kit, and instructions were adequate. It took us about a year to build it, from when we got the kit to when we flew it the first time. I'm a fan of the television program MASH, and was in the service at the time these things were used, and that's what gave us the idea. We do have cattle, and I check my windmills and count cattle with it, but other than that, it's just a toy. Dig up the money and send it in and have them send you a kit. It's not hard to build. Anybody can build one. If I can do it, anybody can do it.
The front strap attaches at the bottom to this bolt here, and you start with just a strip of metal like this. I've already got the hole in this end. Now, years ago, I had a pair of riding boots made by a chap in Spain in his shed, and when I went to have them fitted, instead of measuring my feet as I expected him to, he just pulled a piece of paper off a calendar on the wall, went round my feet and put little tears in it all the way along, and then 3 weeks later I had a perfectly fitting pair of boots arrive in the post back in England. That's the way to do it. So I'm going to take a leaf out of his book. Let's see if I can't do the same thing. So that's green mill, 19. Sorted. Let's see if it fits. Well, you didn't seriously want to watch me just bend a bit of metal in a vise, did you, for goodness sake? Does it fit? Of course it fits. In there like that. Very simple. One nut and bolt at the bottom. I can take the strap off afterwards. And then at the top, I've already got these brackets on for the top fixing. To the no, it's all right. I've saved it. Did you find that funny? You did, didn't you? And that's going to go on there like so. Okay, that's on there for now. That's fine. A lovely snug fit. One strap down, 3 to go. Right, that's it. Tank number 2 in place. The straps themselves will all be sprayed up and then some rubber put underneath them. There's a petrol gauge, fuel filler gauge in here to go in, but that has to be calibrated. We do that later on. So, some connections. And there's 2 of them left. One is this, which is the fuel return from the regulator, like so. And the last one down here is the outlet to the cut-off valve, and then that's it, pretty much connected up. Obviously there's a little bit more work to do on the fuel system, And that includes basically taking all these pipes to the tanks off again so we can get to finish the straps. But it's a good job. Lovely.
Send the helicopter, I do that reducing collective pitch, coordinated with left pedal to maintain heading due to the change in the engine torque. As we descend, once I reach my angle of descent, which I'm referencing between my ground target and the compass, I'm controlling angle of descent with collective and my rate of closure with cyclic. Pass through about 100 feet, I'm going to start reducing airspeed from final approach airspeed, which is about 65, until we come to a hover back on the ground. At some point, we start to lose effective translational lift. I need to re-increase the collective to apply more power to sustain the hover as we come to a stop. Okay, setting up for a steep approach, going into a confined area to clear an obstacle. The beginning of the approach is a normal descent, with the exception as we reach 200 feet of altitude above the ground, we're going to start to reduce our airspeed rather than wait to 100 feet, and we're going to slow our rate of descent so we intercept a steeper angle of approach towards the target. You see this approach angle is much steeper than when we were coming in on a normal approach, and it's much slower.
Ensuring the correct weight and balance and the appropriate position of the centre of gravity on a helicopter is important for safe flight. Same with all aeroplanes. So you need one of these. It's called a ballast weight. It goes in a position there when you've got two in the cockpit, or if you're on your own, it slots down here on this skid. Problem is, it's not heavy enough though. It needs to be 25 pounds, including that bit and the bit that goes on the end. So, to make it a bit heavier, what you need to do is get all this lead here into this tube. To do that, you need one of these and a serious amount of heat. My name's Mark McSetterline. Welcome to the kit builder's version of the Naked Chef. Ooh. Got the pan on the stove just to keep it all warm, and the oxy to melt the lead into the pan, so this obviously comes in these big strips. It's standard roofing lead this, so if you have any problems getting hold of any, just find yourself a church. Can't say that because the whole church will be down on you. Brilliant. That was a bit nerve-wracking, I have to say. A bit of molten lead about. Quite exhausted. You can see how hot that tube's got just by the colour of it. Well, that's it for now. Join me next time when we'll be doing the avionics. It'll be the electrics and the electronics. I have got some serious kit for you, so don't miss it. Until then, be good. Hello, my aviation chums. Yes, I found the key to my helicopter. No, of course not. But it is a very important piece of kit because it is the instrument panel. Yes, that's what we're going to be doing today. It is time for the electrics. In front of me are just some of the instruments that we've got to put in, because I've got a list here. I've got radio, transponder, intercom, antennas, GPS, compass, altimeter. I need joule, temperature, water. It goes on and on and on, and I've got to fit it all. And the worst thing is down here. Look at this. Wiring looms. Right. This is the instrument pod, and this, as you now know, is the instrument panel. This will fit in here, like so, but it's a bit oversized at the moment. You can see I am struggling to get it in here, so it all needs to be filed down until it's a beautiful fit, and that will sit in there against these lugs like this. Now, there's a lot to do, and I said I was going to get some help. Jonathan and David from Southern Helicopters, top blokes, they know what they're talking about when it comes to helicopters. They're helping me with the wiring, because I've got my first guest and he's arrived. Pete, mate, file that, get it sorted, won't be long. Now, there are a few bits of kit I haven't got which I desperately need, so I've invited along my old mate Robin to give me some advice. What are you doing up there?
Just checking the altimeter, Mark.
Thought you grown from a while.
No.
So, it works?
Yeah, it works fine.
Good. Well, that goes with that kit over there. By the way, did you manage to find somewhere to park your tractor?
Oh, yes, yeah, just outside. Yeah.
Excellent, superb, good stuff. To work, though, because I need all this kit, radio, transponder, intercom, GPS and compass. My concern is obviously it's not the biggest aircraft in the world. We want to keep the weight down to absolute minimum, and when you're flying, you've got your hands occupied because you've got a collective and a cyclic to deal with, and there's lots going on.
As you say, really it's the workload, using the stick all the time. The recommended fit would be a communications transceiver, a transponder, and some form of navigation, and it would, of course, now be GPS that you would use. This comm here is configured so that it can be remotely activated from the stick.
Right, brilliant.
Okay,
So you don't have to let go then to be able to switch channels or whatever.
Yeah. So there's no fumbling for buttons or anything, it's just ease of use, really.
So that's fine. So that's a radio. Transponder.
Yep, the transponder, again, we're going to go for a panel-mounted transponder, which will enable the ground to identify your position in the sky.
Okay, so we dial that up in the window. You've got your code. That'll come up and it'll have your blip on the screen with your code on it, so they know exactly who you are.
Yep.
Compass. Now, there's been a kind of new development in compasses which I've been reading about. Explain that.
Yeah, it's not so much new, it's just become more affordable, really. It's a better pictorial picture of exactly where you are in the sky. So you're actually looking at your aircraft on a vertical card, seeing exactly where you're going.
Okay. Last thing, you said about navigation. Everybody's using GPS now. What's the benefit, though, of this over the more traditional kind of VOR type equipment?
Well, weight, again, is a big issue. It's also much, much more accurate. 99% of people are using GPS either as their only source of navigation in this type of flying or as a backup.
Can we fire that one up so we can have a look at what we can see on it? I'm in a rush. I've got wiring looms to put in, for goodness sake. Well, Robin's got it all fired up in demo mode, and we're flying from North Weald to Fair Oaks.
That's right.
Okay. It's a very clear screen, but actually quite confusing when you first look at it. I mean, there's a lot of information.
There is a lot of information on there.
Now, we have here the plane symbol is us, obviously, and our route is the line we follow.
That's right.
So what happens if you're in trouble and you want to find the nearest airport to land or the nearest helipad to land as quickly as possible? What do you do?
Okay, well, we can just hit a button here. Okay, and from that, immediately it will come through with our 10 nearest airports, the bearing that we would need to fly to them, and the distance they are from our current position.
Excellent. So it gives you another route to follow. So, and if you found that the aeroplane, the aircraft icon was off that line, you've got to fly it back on the line.
That's right, yeah.
That's amazing. How accurate is this information then?
Oh, it's down to meters. It's incredibly accurate.
I'll be having one of these then. Anything else that you think I should have?
One of the things that we're becoming more and more aware of now, ELTs, which are emergency locating transmitters. They're the things that go off in the event of an emergency or a crash. This one, for instance, has a forward-facing G switch in it. Okay, so in the event of a crash,
if it gets banged hard,
yeah,
it will
go off.
And how does that work then? I mean,
okay, when the ELT begins transmitting, that information is sent to the satellites. The COSPAS SARSAT satellite then transmits to the ground receiving station, down to Mission Control Centre, and the search and rescue forces.
Better have one of those too then. Pete, mate.
Yeah.
A couple of things you need to know about this box. Yeah. Don't drop it, and don't press the button. Okay? Thanks, mate.
Pleasure.
Rotor and engine needles follow each other together when the engine's driving the rotor system. By making fine adjustments with the throttle, I can increase the RPM. As you see here, the rotor RPM increased to the top of the green, or I can decrease the RPM with the throttle. So as you make power changes with your collective, you need to make small throttle corrections to help maintain the rotor RPM, ideally in the center of the green. Now if we're climbing out, you're going to see the vertical speed indicating to the positive side. Manifold pressure is in relation to how much engine power I'm using with my collective pitch. If I want to descend, I will lower collective pitch. Manifold pressure drops as well. We're using less engine power. Once I reach my new desired altitude, I know that if I go back up to 27 inches of manifold with the collective, we'll restabilize out. Altimeter, in this case, is set to register altitude above sea level. So that puts us 450 feet above the ground. If I put the helicopter in a descent, you'll see the altimeter decrease. If I want to climb back up, you'll see the altimeter increase.
Section 21, the electrical system. Yes, you have your own section in the manual here to refer to, but it's a little bit shorter than I thought it would be. It's only a few pages, which is why I need help. Now, if you're the kind of person who likes putting dials in your 850cc Mini, this kit is for you. Clearly, it looks fantastic. Problem is, how do you fit it? It's not in there, but there is one more piece of paper. It's here. That is all you need to fit it. So, it's all very clear then, isn't it? This is the mounting tray for the radio and the transponder, and it needs to be pop riveted to the back of the instrument panel. Pop rivets will come through from the front, and the holes have been countersunk here. And the little pop rivets are fantastic because they are actually used on the blades, but they are little countersunk pop rivets as well. So not your average pop rivets. They will fit through the 4 holes. It's better to locate all 4 first so you know they're all going to fit. There you go. Fortunately, the instrument panel already comes with its holes cut out for the instruments. You have to modify it a bit, but not too much. Right, those are in like so. And then, standard pop rivet gun. Just keep squeezing. There you go. Got a lovely finish there on the front, nice and flat, which means when I put the fabric over the top you won't actually see where the pop rivets have been. So 1 down, 3 to go. All right, mate?
Yeah, fine. Yeah, carry on.
Leave it, leave it. A little bit of filing, and that is sorted. Now I can cover it. What I need is a piece of sticky black plastic. This is going to be the beautiful finish on my instrument panel. It's very, very light, which is very important. Everything should be light in this helicopter. And the way you do this is lay down the plastic. We don't want any rubbish because it's got to be perfectly flat. Then lay on the instrument panel like so. Cut that out. Now, this is the bit where we get into some sticking. For the wrinkles. Bolt the blade through, just a case of following, almost by feel, the edge of the aluminium of the blade.
So it looks like you're nearly done there. Finished?
Not quite, mate. Well, thanks for the tea.
Okay.
Feet.
What?
Put it down. Right, I've got my sticky black plastic is on and it's all cut out ready for the instruments, and I've got a diagram here in the manual. I'm starting with the airspeed indicator, which is here, the ASI, airspeed indicator. Now what a lot of people do mistakenly is mount it from the front, and it looks exceedingly ugly that way around because that's not how it's designed to go. It should go in from the back, like that, and then it looks lovely. And just 4 bolts to fix it in place. There we go. And then, when that's all tightened up, just keep working from the diagram. The next one will be the dual tacho, then the altimeter, oil pressure, oil temperature, manifold pressure and water temperature. Last 2 bits to go in are the transponder and the radio. Now this will slot in, but you can see at the back it's held in place by this little screw, which is activated by this little Allen key in there. So that goes into its mounting tray. That's done. And then the lovely radio, which should just slot in like so, and it's just got a couple of retaining clips. Now, are you ready for this? Ta-da! Can't wait to see how this fits.
Mark, I've done it. It's all finished.
Mate.
Here we go.
Mate, too slow.
What?
Sorted.
Oh no.
Got a problem?
What are you doing here? While they're here, it would be rude not to have a look at their helicopter. Dave, mate, take me around this beast.
Right, well, this is the Sea King Mark IIIA helicopter. It's been probably, it's based on a 1960s design, so it's been around a good few years, but it's been nicely battle tested and proven in all sorts of environments, and is eminently suitable for search and rescue.
How difficult is it to fly?
It's a very stable and heavy beast, but you can chuck it around if you have to.
Because to be honest, Dave, and I have to be honest about this, you do look as though you're not old enough to have your driving licence.
I had an easy paper round, mate. I really did.
How old are you?
32.
32, and he's flying a bit of kit like this. What did I do wrong? Now, down here, that's the winch.
That's the winch, yeah, which on a search and rescue aircraft is our sole reason for being, really. Right. We're merely a delivery system for our winchman, who is fully paramedic trained. So all we need to do is get him to the casualty on site.
It's being very humble, though, because hovering above a choppy sea cannot be easy, let's face it. So, it is, I mean, I just can't get over the physical size of this thing. I mean, how many blades have you got on here?
We've got 5 up the top.
Is that not slightly over-engineered?
Yes, and I'm more than happy with that concept. What you're seeing there is the blades are designed to fold, just to reduce the footprint.
Oh, right. The big hump in the middle?
Is the radar. We can use that so we can navigate over the sea The radar operator will keep us clear of ships to get us to whatever incident we have to get to.
So what sort of money are we talking for this kit then?
Oh, to put a price on it, really? Several millions of pounds.
Amazing, isn't it?
Yeah.
And on a serious side, though, your search and rescue is obviously, you know, some people do stupid things, some people desperately need you because of real accidents. But what's the message that you'd like to get out to people about search and rescue?
Well, I mean, I know you're looking at installing the beacons and things here. It's always good to have the beacon on board. If you set it off by accident for whatever reason, tell somebody. And then at least we know we won't get all the way there and find it's a false alarm.
So how's air sea rescue organised throughout Britain?
Well, the country's divided into flights. We've got 6 run by the Royal Air Force, 2 by the Navy and 4 by the Coast Guard. And we're obviously one of the Air Force flights based out of Wattisham. Each of the flights designed basically so if you were to draw a circle with the radius of which was 1 hour's flying time, they would all overlap, so you've got instant coverage of the entire country.
So how does it work if you get an emergency call?
Well, we have one crew which is on first standby, so that we would stay, either we'd be flying around doing our own training or we'd be based at the flight itself, and our task is to be airborne within 15 minutes, whatever the call is.
Now, inside, you've seen the outside. I'm putting the avionics in my aircraft at the moment. Can I have a look at yours? Because I gather they're probably a little bit more complicated than mine. And mine are complicated enough, for goodness sake. This is brilliant.
Bit more space than yours, then?
Bit more space, but amazing visibility for such a huge aircraft.
It is. We pack quite a lot in here, but you have to compromise. It is a search and rescue helicopter, so you need to be able to search. And that involves looking out the windows at times.
Some of the dials and switches here are familiar to me, but the majority aren't. Just take me around what we've got.
Let's start from the important place in front of us, which is the flight instruments, which will probably be, as you say, essentially the same as the ones you've got with the AI in front of you. This is a radar altimeter, which gives us our height directly above the ground below us. VSI, compass, and altimeter. Connected with these, you've got the NR, rotor speed, and also the torques going through the engines. Here is the FPC, the flight path control. We can use this to take us from a set height above the sea, and just by working with the radar operator down the back, it will bring us to a fully coupled hover in total cloud, in fog.
That's effectively an autopilot, but for a helicopter.
Yeah, basically.
That is extraordinary. There's a lot to do in this cockpit, so presumably it's a workload for 2 people.
Indeed it is. With the pilot and co-pilot, we've all got defined jobs. Co-pilot will deal with the navigation and the radios en route to the particular incident himself. And the pilot will obviously fly the thing. And then when he gets there, he'll be maintaining the hover in order to put the winchman down.
And so there's the other 2 are in the back.
Indeed.
See where they work. This is amazing. You wouldn't want to find yourself in here for real in a rescue. But if you were, you'd be with these 2 guys, Dave and Nick. So who does what in the back here?
Okay, my job's as radar and winch operator. So it's my job initially to get the aircraft on scene using the radar for navigation and collision avoidance. And then when we arrive on scene, I deliver Nick using the winch to the scene of the incident.
But Dave up front was also saying that you have to do hovering and stuff if required, if you've got better visibility.
That's correct. We have a control beneath the winch handle, which allows me to fly the aircraft in any direction with them controlling the height at the front.
Well, that must be scary. It's scary enough when you're out over the sea, but having complete control of the helicopter as well.
I get that warm, fuzzy feeling where I'm doing everything.
Now, Nick, you're the winchman, aka hero. What makes you do that job? I mean, we are all enormously grateful for the fact that you do, but I mean, it must be unbelievably scary.
It can be at certain situations, obviously, but most of the time it's just job satisfaction, really. You get amazing buzz from taking care of people who are probably in life-threatening situations. If we can get them out of that situation, all the best.
Dave, mate, thank you very much indeed.
Pleasure.
Great to have a look around your helicopter. Before I go, though, and before you disappear, one more question for you. Can you give me the details of the first ever recorded helicopter rescue?
No.
It was 1944 in Burma, and it was a Sikorsky R4. It's always nice to be one step ahead of the professionals. that's it from A Chopper Is Born for now. Pete?
Yeah.
What am I going to organise next time? That was such fun. Gotta think about that.
Morning, Mark.
Morning. Good day to you, sir. How are you?
Coffee.
Thank you very much indeed. Pete, mate.
Yeah.
Park it in its normal place, would you?
Right, mate.
Use battery charger for calibration or operation. Hello, my aviation chums. Welcome to A Chopper Is Born. Or should I say, physics today. Because we've got to calibrate the fuel gauge, and I've got that bit of information that tells me how to do it. And it's a long time since I did physics, and Pete's no help because I don't think he ever did do physics, just masonry, chop things out of stone in those days. Now, what we got here is the sender unit, which will go inside one of the fuel tanks, but this needs calibrating relative to the gauge down here. So it said the first line was mount the gauge in a convenient place, so there it is. Then you connect up the battery to it. In this manometer tube, see, I remember that from physics, it's empty, there's no fuel in it at the moment, and on the top of here are two screws. One says full, one says empty. I have to turn them both fully clockwise, like that. One. Oh, look at that, it's moved, it's over here now. Now I have to move the empty one anti-clockwise until the needle is on the E. Oh, gosh, it's very sensitive. So now, for the dangerous bit. You get the fuel, and you fill this with fuel. Right, now. Right, so that's way off the end there now. So now I turn my full one back until it says full on the gauge. So the big test now. If the fuel was being drained, the equivalent in this little physics setup is to pull the sender out. So as I pull it out, the needle should drop, and it is. And when the sender's about half in, half out, it should be on half, which it is. And then keep going. Oh, there you go. Red light comes on, warns you that you're running out of fuel, rapido. And then when it's completely out, it's on empty. Perfect. Pete, though, it's quite a big bit of kit to put in the cockpit, don't you think?
Yeah, look, it's only that bit's going to go in though, isn't there? We don't need all of that.
Oh, we don't need to put all the wood in?
Just that bit, that'll be fine.
Oh, thank goodness you're here, mate. The last gauge to go in the pod is the hour meter, which gets switched on and starts timing as soon as the instruments are switched on. And it's very important because it allows you to work out when you've got to service the aircraft and so on. The pod's moved on a little bit. We've already got these gauges in here. A full range tacho, which is a kind of backup to the one that's on the main instrument panel. Voltmeter, fuel pressure, and this temperature gauge is a temperature recorder for a sensor that's on the secondary drive bearing. So these are very important instruments, but this one's going to go in here like that, and it's a very simple job. Right, last job on the bench is to put on the GPS mounting bracket. It's just got 4 bolts, and it bolts through the top of the pod here. So it's in good view of the pilot. So there is the baby. This will fit in here, but we need to put in wires first. Drops in like that. Slots, look at that. Lovely jubbly. Right, let's see if we can get something on it. Ah, good job, mate. Nice one. Rocking. He is good though, isn't he, eh? Pete there. It's amazing you don't see him on a main channel. Right, I can drop the pod back onto the airframe. Just rest it down there because the collective lever has got to come up and through this slot. So, drop there and there. It sits on these adjusters. There's 4 of them across the front, so we'll sort that out when we actually put the rest of the bodywork on, because this is fixed to the bodywork, not the airframe. But hey, starting to look like a helicopter at the front here. Now, next job is to put in the main instrument panel. Then the instrument panel will go in there, together with a huge amount of wiring. If this looks complicated, it's because it is. What a jumble. With a little bit of jiggling. Oh, there we go. It will slot in. And then it'll take up the shape of the panel when all the screws are in place. Just looks fantastic. Now to wire up the instrument panel, so wish me luck. The diagram is actually very useful, but you do need to kind of follow it extremely carefully. I'm going to wire up first these instruments here. Now on the wiring diagram, they are down here. Slightly confusing because these actually are in the order you'd see them from the front, but actually the numbers here refer to the terminals on the back. So let's start. We know up here that all the numbers 4 are red, are positives, the 5s are black, are grounds or earths. Okay, so we'll start with this one here, which is the fuel pressure. The one on the left is positive at the top there. So that's that. And the one on the right is a negative. Right, so that's got its power supplies. Now, full range tacho, we've then got terminals 2 and terminal 7. So if we follow terminal 2 round, there. So I need wire 15 onto terminal 2. That is wire 15, so that needs to go onto the top terminal. Yeah. This is the wiring harness for the engine management system, which is the next bit to go in, and it fits down in here like this. These big plugs go onto the electronic control unit. I'm just going to clip the harness or the wiring loom in place there, so it hangs in roughly the right position. Then I've got to work out, with reference to my wiring diagram, where all the other plugs go and then lay them out into the right places before connecting them. And all these plugs go to things like injectors, map sensor, primary air temperature, because all these things have a primary and a secondary backup circuit. Lots and lots of plugs. So I'll check it on here and check it on the actual engine itself, but I know the long ones must go over towards the other side. Now, it's called a FADEC harness, this, because the engine management system goes by the name FADEC, and I have absolutely no idea what FADEC means, but I know a man who does.
The FADEC is a fully automatic digital engine control system that is going to drive your engine. With any electronic control system, as you have in your car, if that computer fails, you're going to coast to the side of the road and stop. Obviously, we don't want that happening in the air. We have 2 engine computers and backup for all of the critical systems, including the ignition, the fuel, throttle position, and should any one of those items fail on your primary system, we automatically transfer to a secondary and you keep flying. This is the dyno. We actually install your engine, hook up all the systems. We plug in your ECUs, and what we're going to do is we're going to run your engine up and slowly bring it up to maximum power full load using the water brake and find out what parameters you need in your ECUs to get peak performance from your engine. This is the control panel that's going to allow us to run your engine up and really test out all of the systems to make sure that it will run at peak performance by programming your ECUs and that we have all the systems working properly. We have a computer that we have connected to these ECUs. And as the dyno is running, we're going to look at all of the signals and values that are being put out by the sensors on your engine. We'll then peak it for peak performance for your ECUs matched to your engine.
So now you know how it works. All I've got to do is plug it all in. Got injector 3 and injector 4. That's injector 3 on the top, and that's the other one. Right, next ones are secondary injectors, which are under here. Next is the primary air temperature, and secondary is on there. Next, the throttle position sensors. This is the throttle, but it's sensed here, which is that one. Primary. It's there. Time for a break. Join me afterwards when I'll be finishing off the wiring down here, putting in the ECU, which is the electronic control unit, and the ignition packs, ready for testing. We'll also be putting on all the lights, and then later on in the program, we'll be starting on the bodywork. Welcome back to A Chopper is Born. Now, I thought learning to fly a helicopter was complicated, but actually wiring it up when you're building it is even more so. But I'm getting there. The computers are in, the ECUs, the electronic control units. There are two computers in this box which constantly interrogate each other. Now, this pack will sit on the underside of the seat when it's in place. So we'll be taking the crate away, of course. Also in here now, just suspended temporarily for testing purposes, are the ignition packs. They're all wired up and ready to go. There's a few more connections I need to do, but first, before I can test it all, I need to put on the lights. Take me to your leader, take me to your leader, take me to your leader. Anti-collision lights first. The one at the back is red. It just pops in here. There's two anti-collision lights. You don't have to have anti-collision lights, but I think it's completely stupid to go flying any aircraft and not have as much visibility as possible. There's a white anti-collision light that will just dangle on the front for testing purposes, because we can't actually fix them all until the body's on. And there's a control unit for the anti-collision lights, which is back there, which you can set for different flash patterns, and the one that I've set up for this is to have 3 flashes of this one at the back and then 3 flashes of the one at the front, which is called a comet flash. So that's on there. Just plug that up. Finally, the nav lights, the red one on the port side over there, and then the green one on the starboard side here. Right, last thing is the battery. It's a standard 12-volt wet battery, but it's an aviation battery rather than a car battery, obviously. Just got 2 positive connections down this side. So that's on there like that. And then this side are the earth connections. It's a bit worrying, this. Nothing happened, no lights on. That's good. Right, I can just slot that in. I've already put on the overhead switch panel that's dangling off the airframe up there. That will fit into the top of the cockpit on the aircraft when the bodywork's on. Sorted. Right, now it's time for the big test. Am I going to do it or are you going to do it, Pete?
No, I don't know. You do it.
Shall I have a cup of tea first?
Yeah.
Think?
Yeah.
Yeah, and then we'll come back and do it later, just in case it doesn't work.
Welcome to Oshkosh.
My name's Donna. We built a rotorway exec, 162 Pro, because we have the cog belt, so we call it a Pro. We've been working on it 2.5 years and got it certified in March of this year. It comes with blueprints, it comes with books, and it comes with videos. You know, you spend probably 5 hours thinking to 5 minutes working. Contact with other builders, that was our best thing. Rotorway is open during business hours, and we're working. We're working on this thing nights and weekends. When Rotorway isn't open, you got a question, you just got to stop until they're open and ask them, you know? You can't do that. It's an intense process to build one of these.
Right, had a cup of tea. Pete, do you think we should have another one?
No, get on with it.
We start with FADEC 1. Woo! FADEC 2. Second green light. Superb. Now, instrument panel. Oh, look at that! Red lights everywhere. GPS. There we go. Fantastic. Right. Lights. Nav lights first. Yes! It's like Christmas. Yes, and it's working at the back too. Superb. Next, strobes. There we go. Now, if you are sensitive to flashing lights, or you think you might be, look away now. 3, 3, Comet, superb. It's all working. Switch those off. You can look again now. Right, so they worked. Landing light. So cool! Now, comms. So that's the comms master switch and the transponder master switch. And then I'll switch it on down here. Right. Is it working? Yes, do you want to listen to it? Here you go.
450, runway is 05, ground.
Exciting or what, eh? The next job is to start putting some bodywork on.
Taxiing the helicopter here. The purpose of that is to move it from one position to another on the airfield. For a forward taxi, I'm referencing the ground in front of the helicopter, using my pedals to maintain directional control, collectors maintaining skid height above the ground, and my cyclic by applying slight forward pressure, I'm able to move the helicopter forward in a straight line of movement. We can also side taxi the helicopter. We would do this if we were fighting the wind. Rather than put our tail into the crosswind, we can keep the nose of the helicopter into the wind. Again, using pedals to maintain directional control and using the cyclic pressure in the direction I want the helicopter to move. Slight aft cyclic pressure allows the helicopter to taxi backwards. Now with total coordination of all the controls, you're able to turn the helicopter and continue to taxi in one general direction. So I would say that's probably extremely coordinated because you're constantly changing the cyclic towards the direction you want the helicopter to taxi. Then you're changing pedal positions to keep the helicopter rotating around.
The first bit of bodywork to go on is this, which is the tub, which is like the kind of undercarriage, if you like, of the main body shell, which will slide in because we've taken off the front landing gear to be able to get this on. I've also taken off all the electrics that I put on earlier temporarily, like the overhead switch panel and the ignition packs and so on, so they're not in our way. Now, just watch the wiring down here, mate. Okay, your side? Yeah. Right, there's a cutout, Pete, at the back there that will go over the rear landing gear. Okay? Oh, ow.
Yeah, that's fine, look.
We need to support the front end with our favourite old wooden crate and a bit of packing to keep it up at the right kind of height so that I can get the landing gear back in again, which is a bit fiddly.
How's that?
Yeah. Oh, what sort of angle are you on at the moment? Hold on. Sliding off, are we? Right, I need to line those up and drop in little bolts.
Here we go.
Right, keep yours fixed.
Yep.
Okay. That's one. Yeah, it's no, he's right.
There are only 2 holes there, aren't there?
Next, 2 bolts, one either side, that attaches top of the landing gear to the airframe. Put that in, what, this way? Oh, just so you can line it up. Just line it up, mate.
Okay.
This is a man who's never so much as even put up a piece of shelving in his life.
I have.
Ooh, I have.
Oh, got it? Oh, yes.
Now. Sorted?
Done.
Most of the panels on the aircraft are held together with these little nut plates, which has a screw coming through one panel, and then this nut plate is pop riveted onto the second panel. There are 307 of these on this aircraft, and unfortunately, they all have to be painted white. So, it's a bit big, this, Pete.
Is it? Oh, do your best.
It's going to take me hours. That's it for now. Leave me with my painting, and I'll see you next time. By the way, Pete,
Yeah.
there are supposed to be 307 of these, and there are only 306 here.
So?
You had it?
No.
I know what you're like. He nicks something from everything we build as a little souvenir to have on his mantelpiece. Are you sure?